right, so continuing on with Chapter 6, we talked about the formulas in the earlier video, 6.2, some of the formulas that you'll see throughout this section, so, and also throughout the book, but I'm going to do the problems that I asked you to do, the activities from the last video, and some samples here with you. So again, if you didn't get a chance to do that, please go ahead, pause it, and do those now. So there's 7 practice problems on the last page of 6.2. So the first one comes in using the simple interest formula. We learned I equals PRT, and all the ones we did in our practice ones, though earlier, we knew P, R, and T when we saw them for I, so it's a little easier. These take it up a notch, and it tells me the interest you earned was $100, and we don't know the principal at 6% for 3 years. So we're going to have to do a little more equation solving. So simplify down the right side. You know, we always simplify as much as we can on each side before you start solving. So multiply that out on your calculator, and that's going to be 0.18. And then to solve that, I'll get my calculator out. I'm going to tell them I'm going to need that. So then we do our equation solving, and we say whatever is multiplied onto the variable, and usually you see that in front of the variable, don't let that bother you, is still multiplied on the variable. We do the division, the opposite, and we divide that, which cancels that out. A multiplied thing that's then divided cancels out and becomes 1, or 1p. What we do to one side, we do to the other side. And so 100 divided by 0.18 is what we need to do, which comes out to be $555 and 5 repeating. I'm going to round that to the nearest penny, 56 cents. So you could check it and see if that principal plug back in times 0.06 times 3. That's how we'll know if we multiply those 3 things together, is it 100? Okay, number 2, compound interest. So we had a formula, A equals P times 1 plus R over N raised to the NT. And it says find A, so good, we won't have to do any working backwards here on this one. Find A, so A is isolated and we know all the players. P is 500, R is it's 3.5%, guys, so you do need to move that to left always, 0.035. Says N is 2, and then T is 5. In the last video, we talked about the importance of telling your calculator that that was also in a parenthesis. Even though it's not necessarily written that way, we need to tell our calculator both of those are in the exponent position. Then type away. 500. Some of you have to put the times sign there, some do not. I think most don't. And then do divided by 2, and then up arrow. Either go ahead and call that 10, or do 2 times 5 in a parenthesis. Either way, you'll get the right answer. Let me tell you what that should be. Sorry, I didn't already have this worked out. I should have done that already. You get $594.72. So that's what your money would grow to. If you invested $500, you left it in there at 3.5%, compounded twice a year for 5 years. It would then grow to or accumulate to $594.72. It's a compound interest formula. Okay, number 3. My marker does not want to erase, so I apologize. I have to chisel it off the board, I'm afraid. Okay, number 3. Number 3 is a statistics formula. We talked about z-score equals x bar. And these formulas are on your former page. If you need to look back at those, we wrote all those down. Is x bar minus mu over sigma. And so it gives us values to plug in. It says determine z. If you know x bar is 70, u is 65, and sigma is 10. If you're doing it on your calculator, you need to parenthesis the 70 minus 65 divided by 10, or just do it by hand. 70 minus 65, that won't hurt us, right? 5 divided by 10 is a half, or 0.5. Number 4, we're going to use that same formula. We use that same formula, but this time we know the z value, and we're trying to figure out the mu value. Let me try another marker. Maybe that would be the smart thing to do today. Let's see if this will help. Okay, number 4. It'll either be, not be worse, we'll see. Okay, same formula, the z-score formula that we have. It says plug in, you know z to be 1.2. We're looking for x bar. Oh, no, it tells me x bar is 70, sorry. I looked at it wrong. We know x bar is 70. We don't know the mu, sorry. And then sigma we know is 10. So we're plugging it in, and we have to do some equation solving. So what I would recommend, the first step here is clear this fraction. So we learned a technique in the last chapter where we times by this LCD. This is over 1, by the way. So the only denominator we need to wipe out is this 10. So if we times by 10, those diagonally cancel out, but we have to times this side also by 10. So 10 times 1.2 on the left side is going to make 12. And then on the right side, this is wiped out, so it's just this numerator, 70 minus mu. And then there's some different ways to do this, so you need to move things around. I think I'll leave the variable right where it's at. There's only one variable term. Move my constant, my number to the other side, making it minus 70. 12 minus 70, what is 12 minus 70? I can't subtract upside down there, so let's try. I think that's 58. Negative 58 though, 12, if you had $12, you took away 70, you'd be in the hole $58. Can y'all still see that? Yeah. Okay, so this is like a negative sign in front of that. It's like a negative 1 in front of that, so you do need to divide out the negative sign. We're always looking for like positive x or positive u or positive p, whatever the variable is. We can't have a negative left on it, so we divide out that negative 1. Always divide out the negative sign if you see a negative left on your variable. So then it divides the other side by negative, and then it solves for the u or mu, and negative over negative makes that positive 58. So the final answer, and you can check it, is 70 minus 58 equal, divided by 10, should be 1.2 back in the original. Okay, number 5. All right, our next example is from graphing. It says solve these for y. So this is real good prep for what we're getting ready to do in the next little bit. Solving for y to help us graph. So if we have an equation in terms of x and y, so two variables, we're trying to solve for the y variable, get y alone, y equals. So the x term, if it's not already, throw it to the right side. Leave the y on the left side, or move it to the left side if it's not already. You know, we can move terms all day long. Moving them back and forth across this equal sign just changes their sign. So you want the y on the left side, and then any x terms thrown to the other side, changing its sign if it moves over. The 6 was already there, so bring down a plus 6. Okay, so you move your terms around, so y is on this side and everything else is on the other side. And then you divide by what's on that y. To get rid of the front value, we divide by the same exact number. Negative divided by negative, that makes that positive 1y, or just y. What you do to one side, you do to the other side. Now that is the answer. We could leave it like that and it wouldn't be wrong, but we could clean it up and be in a better form. So what we should do is we should say both of these are divided by negative 3. So we've got two fractions. Negative over negative makes that a positive 2 over 3 with the x, and then this 6 is also divided by negative 3, which is a minus 2. And that would be our best form, y equals, and this is going to be important to us later, this is the slope of our line, and the y-intercept where it crosses the y-axis. It will help us graph it in the next little bit. All right, so again, try number 6 if you haven't already. Use this method, practice that. So on number 6, we're doing the exact same thing. We're solving this equation for the y variable. We're always solving for the y variable when we're using this technique in graphing. We throw the x term to the other side. Again, keep the y on the left, the x on the right. So we bring this as negative, bring it down, it stayed on the left. Taking this to the right will make it positive 3x. The 15 was already there. Then you divide by what's on your y, so divide by exactly the same sign to get a positive 1y or y. Do the same thing to this side. This creates two problems, this over this and this over this. So 3 over negative 5, because the signs are different, you can just put a negative in the front of it, or or on the top or bottom, that doesn't matter, but typically we just put it in front of the whole fraction, x, and then 15 divided by negative 5 is negative 3. That doesn't always come out perfect. That could be a fraction as well, to be aware. All right, one more problem, number 7. The last thing I asked you to do is find the Celsius when it's 55 degrees Fahrenheit. Oh, where's that formula? We have a Celsius Fahrenheit formula. Oh, it's right above there. We have Fahrenheit equals 9/5 C plus 32. And then earlier, we rearranged it and found out that it'd be F minus 32 times 5/9 if we rearrange that for C. So you can use either one of those formulas for this number 7. The handier one to do when you're trying to find Celsius is use the one already solved for C, solved for Celsius. And it says plug in 55 degrees Fahrenheit. So that way we can punch it on our calculator. 5/9 times 55 minus 32, or do it by hand. 55 minus 32 is 27. I picked a number that would come out even. It does not always though. But then you can do 5/9 times 27, and that cancels that out to a 3 times 5. That should be 15 degrees in Celsius. 55 Fahrenheit should convert to 15 degrees in Celsius.